we are going to explore the key elements of the Hadoop infrastructure. First, we have name node. The primary purpose of the name node is to manage the metadata for the HDFS. Now, considering that no processing on a Hadoop cluster will happen without HDFS working properly, one of the key tasks for the name node is to remain accessible. And that would naturally lead us to install it on a machine that should be more reliable than the nodes on which we are doing the processing. The metadata, which is the information about our files, is held in RAM. And this is why the machines that are running the name node, they should have a lot of RAM. Another term that occasionally shows up in discussions of Hadoop is the secondary name node. And many people believe by mistake that this is the backup for the name node for high availability. And that is not correct. Secondary name node is not a backup, and its purpose is to offload some of the housekeeping tasks to another machine. The second part of our hardware infrastructure consists of data nodes. Data nodes are going to do the processing, and they also store the data in normal files. We have seen that HDFS is built on top of the ordinary Linux file system. Now, the name node is going to access the data in the HDFS cluster, and the name node needs to know what are all the different blocks that are needed to assemble a file and treat it as one unit. So the programs will read the data from data node directly, having direct access to the data. And we already mentioned that a typical organization is that the large files are split into blocks, usually 64 or 128 megabytes of blocks. And having larger blocks makes for easier management. Our processing consists of map and reduce tasks, and these tasks are running on our data nodes. One of the interesting things here, which makes Hadoop different from traditional processing of data with databases, is that we are not going to send the data to the program. Instead, we are going to send the programs, in our case our map and reduce jobs, to the data nodes, and the processing will happen there using the data which is stored on the local disks. If you think about how this map and reduce task run on nodes, we can examine a cluster. In this cluster, we have a set of nodes, here represented in blue. These nodes contain data, and these are our data nodes. On the left, you see the master node, which also has the name node. When you write MapReduce program, the first thing that you will do is you will copy this MapReduce programs to each of the nodes that contain data. So this copying is the first part of our processing. And the map and reduce jobs will process the data that resides on the disks of these machines. Naturally, you need somebody to coordinate and keep track of the execution, and that is the purpose of the job tracker, which executes on the master node. Now, when you have this Hadoop infrastructure, you need to manage it in some way. You need to deal with standard tasks like starting and stopping the servers, adding and removing the servers in our cluster, and also you may want to view what is happening on a particular server. You may want to examine the log files. In the beginning, the Hadoop management tools were rather sparse, but as Hadoop was getting more and more mature, we have seen that there is a larger number of tools. Some of them are open source tools, but particularly vendors who are providing some additional value on top of the open source are coming with very appealing user interfaces that allow us to very effectively control our Hadoop clusters.